Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I'm going to tell about the definitions and terminology on lasers and fiber optics. So, in this definition and terminology in the module 3, lasers and the fiber optics are first question, write the abbreviation of laser. So, write the abbreviation of laser. So, the word laser is an acronym of light amplification by stimulated emission of radiation. So, laser is an acronym for light amplification by stimulated emission of radiation. So, LASER. So, this is light is amplifying, that is amplification, and this has happened by the stimulated. E stands for emission or for radiation. So, light is amplifying through the stimulated emission of radiation. So, through the light amplification by the process of stimulated emission of radiation. So, laser stands for light amplification by stimulated emission of radiation. Write the abbreviation of MASER. So, the word MASER is an acronym for microwave amplification by stimulated emission of radiation. Microwave amplification by stimulated emission of radiation. So, here light is amplifying. Here we are using in the MASER microwave amplification by stimulated emission of radiation. Define the term stimulated emission of radiation. So, now we are telling about that laser is acronym for light amplification by stimulated emission of radiation. So, what is a stimulated emission of radiation? Let's see what is the stimulated emission of radiation. Stimulated emission occurs when an atom or molecule in an energy level above the ground state interacts with the photon that has energy equal to that between the atom or molecule's current energy level and a lower energy level. So, here to define the stimulated emission of radiation, first we shall see the different energy levels. Suppose E1 is the lower energy level. So, E1 is the ground state energy level. E2 is the excited state energy level. E2 is the excited state energy level. So, here in this definition, stimulated emission occurs when an atom or molecule in an high energy level above the ground state, that is higher energy level. So, in an energy level above the ground state means that it is in the excited state or it is in the higher energy state. So, stimulated emission occurs when an atom or molecule in the higher energy state interacts with a photon. So, where this photon is interacting at the higher energy state that has energy equal to the between the atoms or molecules current energy level. So, this photon's energy transports to the atom or molecule which is in the higher energy state. So, when interacts with a photon that has energy equal to that of between the atom or molecule's current energy level and a lower energy level, then the stimulated emission of radiation occurs. So, at E1 energy state, there is an atom. This is an atom. So, when it absorbs some radiation, it excites to higher energy state. When it excites to higher energy state, then two processes takes place. That is, stimulated emission and spontaneous emission. So we are talking about only the stimulated emission of radiation. So here there is two energy levels, suppose E1 and E2. E1 is the ground state energy level, E2 is the excited state energy level. So here, when an atom in the higher energy level interacts with the photon, so it interacts with photon at the higher energy level. So which have the energy equal to the difference between the two energy levels. That is, it has the energy E2 minus E1. So an atom which is at the higher energy level interacts with the photon which has energy equal to the energy difference between the two energy levels, then it transits to lower energy by emitting two photons. So this process is called stimulated emission of radiation. So stimulated emission of radiation occurs when a higher energy state atom interacts with a photon which has the energy equal to the energy difference between the two energy levels. Then the atom transits to lower energy level by emitting two photons. So this is called stimulated emission of radiation. Define the term spontaneous emission of radiation. So define the term spontaneous emission of radiation. So in an atom in an excited state, it may spontaneously decay. It may spontaneously decay into a lower energy level after some time, releasing energy in the form of a photon, so which is emitted in a random direction. This process is called spontaneous emission. So E1 and E2, E1 is the ground state energy level, E2 is the excited state energy level. So here there is an atom which is in the excited state. It may spontaneously decay into a lower energy level after some time. So after some time, so the atom itself spontaneously decay into lower energy level by releasing energy in the form of photon. So this photon energy is equals to energy difference between the two energy levels. So this process is called spontaneous emission. Define the term absorption of radiation. Absorption is the process in which optical energy is converted into internal energy of electrons, atoms or molecules. When a photon is absorbed, the energy may cause an electron in an atom to go from a lower to a higher energy level. So E1, E2, lower energy level and excited state energy level. So there is an atom which is in the lower energy level. So some radiation has been given to this atom so that this atom stimulate and transits to higher energy state. So because of interacting of photon, this ground state atom absorbs some radiation, gains energy so that it stimulates and transits to higher energy level. So this process is called absorption of radiation. So absorption of radiation, it is the process in which optical energy is converted into internal energy of atoms or molecules. When a photon is absorbed, the energy may cause an electron or atom to go from lower energy to higher energy level. Define lifetime. An atom in an excited state does not instantaneously de-excite. So, the atom which is in the excited state, it does not instantaneously de-excite from that energy state. So, the time that it spends on an average in that excited level is called the lifetime of that state. So, lifetimes can vary in duration depending upon the atom and on the energy level. So, when the atom transits to higher energy level, it won't be there for a long time. So, it may de-excite after some time and transits to lower energy level. So, how much time it may spend at the higher energy state, that time on an average is called lifetime of that energy level. Define metastable state. Metastable state is an excited state of an atom or other system with a longer lifetime than the other excited states. Atoms in the metastable state remain excited for a considerable time in the order of 10 power minus 6 to 10 power minus 3 seconds. So, metastable state is nothing but where the atom is stay longer lifetime when compared to the other excited state. So, that's why metastable state is an excited state of an atom with a longer lifetime compared to the other excited states. So, atoms in the metastable state remains there in the excited state for considerably the time which is in the order of 10 power minus 6 to 10 power minus 3 seconds. So, when talking about the spontaneous emission, so the atom which is in the excited state spontaneously decay transits to lower energy level by emitting some radiation. So, spontaneously decay being said, so after the lifetime at the excited state means the 10 power minus 8 seconds, after the lifetime means, so 10 power minus 8 seconds that at the excited state, the atom itself spontaneously comes to lower energy state by emitting radiation. So, this is in the case of spontaneous emission of radiation. So, when we are talking about the metastable state, so in the metastable state, the time is considerably 10 power minus 6 to 10 power minus 3 seconds, which is a longer lifetime than at the excited state. So, metastable state is nothing but where the atom is stayed longer lifetime at the excited state compared to the other states. Define population inversion. When the population of higher excited state is more than the population of lower state is called population inversion. So, the population of higher excited state is more compared to the lower state. Usually, that is generally, ground state energy level have more population compared to the excited state. So, let's suppose E1 is the ground state and E2 is the excited state. Let N1 is the number of atoms per unit volume in the ground state. N2 is the number of atoms per unit volume in the excited state. So, in generally, the number of atoms per unit volume in the ground state is greater than the number of atoms per unit volume at the excited state. So N1 is greater than N2 in general. But in population inversion, the condition will be reversed, that is N2 is greater than N1. So that's why here more number of atoms will be there in the excited state compared to the lower energy state. So the population of higher energy state is more than the population of lower energy state, then it is called population inversion. That is, we can say N2 is greater than N1. What is the need to achieve population inversion? When population inversion is achieved, the majority of atoms are in the excited state. This causes amplification of the incident beam by stimulated emission, thus the laser beam is produced. So what is the need to achieve population inversion? Because we want to get the laser beam. So we want to get laser beam. So as we know that the characteristics of lasers, it has a high intensity, high directionality, monochromaticity, less divergence, so that to get the laser beam, the light should be amplified. The light should be amplified. So this light should be amplified through the stimulated emissions. To occur stimulated emission, we want to achieve population inversion. So when population inversion is achieved, majority atoms will be in the excited state, so that we can amplify the incident beam by the stimulated emissions to get the laser beam. So when population inversion is achieved, the majority of atoms are in the excited state. That is N2 will be greater than N1. So this causes amplification of the incident beam by stimulated emission. So thus the laser beam is produced. Which process gives the laser its special properties as an optical source? In stimulated emission, the photon produced is of the same energy to the one which caused it. Hence, the light associated with the stimulated photon is in the phase. Therefore, in contrast to spontaneous emission, coherent radiation is obtained. The coherent radiation phenomena is in laser provides amplification, thereby making laser a better optical source than LED. So, in the stimulated emission, photon produced is of the same energy to the one which caused it. Hence, the light associated with the stimulated photon is in phase. So, therefore, in contrast to spontaneous emission, coherent radiation is obtained. The coherent radiation phenomena in laser provides amplification, so thereby making laser to get better optical source than LED. What is the law which can mention population of atoms in an energy state? So here the law is Boltzmann distribution law specifies what fraction of atoms are found in an energy state for any given temperature. Define gain medium of laser. A laser gain medium is a medium which can amplify the power of light. A laser gain medium is the medium which can amplify the power of light. Typically, it is in the form of a light beam. What is pumping in lasers? So, for maintaining a state of population inversion, atoms have to be raised continuously to excited state. It requires energy to be supplied to the system. The process of supplying energy to the medium with a view to transfer it into state of population inversion is known as pumping. So usually the ground state atoms be more than compared to the excited state. So to achieve population inversion, that is to make N2 is greater than N1. So in general case, as I told in the previous slide, N1 is greater than N2. But to achieve population inversion, you should make N2 is greater than N1. So to achieve population inversion, that is to get the light amplified, light, there should be more number of atoms be at the higher energy state. So that we should make N2 is greater than N1. So to make N2 is greater than N1, we use different mechanisms. So that is pumping mechanisms. So we have different types of pumping mechanisms. That is optical pumping, electric discharge tube, elastic inelastic collision, chemical reaction. Like that, we have different pumping mechanisms. But what is pumping means that to make more number of atoms in the excited state is called pumping. So that is the required energy supplied to the system to make more number of atoms in the excited state is called pumping. So for maintaining a state of population inversion, atoms have to be raised continuously to excited state so that N2 becomes more than N1. So it requires energy to be supplied to the system. So to achieve this, it requires some energy. So we need to supply some energy to the system. So the process of supplying energy to the medium in view of transferring it into the state of population is called pumping. So in optical pumping, we use some flash lamp. When the light flashes, when the tube gives flashes, so it just gives required energy to raise the atoms higher energy state to get population inversion. So that is pump. What is optical pumping in lasers? Optical pumping is a process in which light is used to raise. That is, light is used to pump electrons from lower energy level in an atom or molecule to higher one. So it is commonly used in a laser construction to pump the active laser medium so as to achieve population inversion. So optical pumping, it is the process. So we use light as an energy source. So when the light flashes, that is when the tube flashes, so because of the flash, the atom rises to higher energy levels. So that population inversion takes place so that we can get laser beam. What is electrical discharge pumping in laser? In this method of pumping, electric discharge acts as the pump source or energy source. A high voltage electric discharge is passed through the laser medium or gas. The intense electric field accelerates the electrons to high speeds and they collide with the neutral atoms in the gas. As a result, the electrons in the lower energy state gains sufficient energy from external electrons and jumps into the higher energy state. So, electric discharge tube use it to pump the electrons to higher energy state. So, electric discharge acts as a pump source. A high voltage electric discharge is passed through the laser medium or gas so that the high intensity of electric field accelerates the electrons to get high speed and collides with the neutral atoms which is in the medium, that is gases, with the neutral atoms in the gas, so that the electrons in the lower energy state gains sufficient energy from external electrons and jumps into the higher energy state. What type of laser could cause skin cancer if not used properly? So, excimer laser. Excimer laser. It is a type of laser. So, excimer laser could cause skin cancer if not used properly. List the characteristics of a laser. Characteristics of a laser are high directionality. It has directionality, coherence, monochromatic, and high intensity. These are the characteristics of laser. Which one is a unique property of laser? Coherence is an important characteristic of laser beam because in laser beams, the wave trains of the same frequency or in phase. Due to high coherence, it results in an extremely high power. Which type of laser is an example of optical pumping? So, atoms of ruby are excited with the help of photons emitted with the help of photons emitted by an external optical source. So, the atoms of ruby are excited with the help of photons emitted by an external optical source. So, the atoms absorb energy from the photons and raises to excited state. So, therefore, ruby laser is an example of optical pumping. Explain optical resonator in laser. So, one of the component in the pumping. So, here an optical cavity, resonating cavity or optical resonator is an arrangement of mirrors that forms a standing wave cavity resonator for light waves. Optical cavities are major components of lasers surrounding the gain medium and providing feedback of the laser light. Light confined in the cavity reflects multiple times, producing standing waves for certain resonance frequencies. What is the principle of fiber optical communication? In optical fibers, the light entering the fiber does not encounter any new surfaces, but repeatedly they hit the same surface. The reason for confining the light beam inside the fibers is the total internal reflection. So, the principle of fiber optical communication is the light entering the fiber does not encounter any new surfaces, but repeatedly they hit the same surface because it encounters total internal reflection. That is, when the incident angle is greater than the critical angle, then the incident light encounters the surface of the core get reflected totally into the same medium, so that multiple reflection takes place in the optical fiber. So here, suppose this is the optical fiber, so light is entering. So this instant light is greater than the I theta is greater than the IC. So instant angle is greater than the critical angle, so that the instant light, when it encounters the surface of the core and cladding, it reflected back into the same media. So again it encounters I theta is greater than IC, so that it reflected back into the same medium. So like that multiple reflection takes place, so that we get the light, that carrier wave as the output. So light entering into the fiber does not encounter any new surfaces. So it encounters the same surface repeatedly, hit the same surface, because it encounters total internal reflection. So when I theta is greater than that, incident angle is greater than the critical angle, then the light reflects back into the same medium. So the light totally reflected back into the same medium. This is called the total internal reflection, and total internal reflection principle, the optical fiber communication works. What are the different components of optical fibers? So an optical fiber has core, cladding, and an outer jacket. So there is core, cladding, and these are the outer jacket or buffer jacket. These are the three components which is in the optical fiber: core, cladding, and buffer jacket. So the total multiple reflection takes place between core and cladding. Define core of the optical fiber. So the core of your optical fiber is the region in which light is guided. The core is a region of slightly increased refractive index. So that's why here core refractive index is N1, which is greater than the cladding refractive index, so that light can be guided through the region of core. So the core of a optical fiber is the region in which the light is guided. The core is a region of slightly increased refractive index. Define cladding of the optical fiber. The cladding causes light to be confined to the core of the fiber by total internal reflection at the boundary between the two surfaces. It has a lower refractive index compared to core. So the cladding causes light to be confined to the core of the fiber by total internal reflection. So the core and cladding refractive indexes are slightly changed as N1 is greater than N2, so that when the light entering into the core, it may encounters the surface interface. It encounters the interface of core and cladding, such that because of the variation of refractive index, the light reflected totally back into the same medium. When it hits at the bottom, there also it encounters interface of core and cladding. So again it reflected back into the same medium. Like that, the total internal reflection encounters at the boundaries between the core and cladding. So it has lower refractive index compared to core. That's why N2 is greater than N1 is greater than N2. Define Snell's law. Snell's law, also known as law of reflection. Law of reflection. It is an equation that relates the angle of incident light and the angle of the transmitted light at the interface of two different mediums. Snell's law states that the ratio of the sine of the angles of incidence and transmission is equal to the ratio of the refractive index of the materials at the interface. So mu is equals to sine I by sine r. So Snell's law states the ratio of the sine of the angles of incident and transmission is equal to the ratio of refractive index of the material at the interface. Define refractive index of the medium. Refractive index is also equal to the velocity of light c of a given wavelength in empty space divided by its velocity v in the medium. Define acceptance angle. It is the maximum angle of a ray hitting the fiber core which allows the incident light to be guided by the core. Define acceptance cone. It is the cone in which the light incident at acceptance angle or less than the acceptance angle, and then the light can propagate through the fiber after total internal reflection. Define numerical aperture. Numerical aperture is the light gathering capacity of an optical fiber, and it is given by sine of acceptance angle. So Na is equals to root of n1 square minus n2 square. So it is the light gathering ability or light gathering capacity of the optical fiber. And also it is the sine of acceptance angle I maximum. Define a fractional refractive index change in optical fiber. The fractional difference delta between the refractive indices of the core and the cladding is known as the fractional refractive index change, that is delta. So n1 minus n2 by n1. So this is the fractional refractive index change. So the fractional difference between the refractive indices of core and cladding is known as fractional index change. How does the refractive index vary in graded index fiber? The refractive index of the core is maximum along the fiber axis and it is gradually decreases. Here the refractive index varies radially from the axis of the fiber, hence it is called graded index fiber. Give reasons for the distorted output. When rays travel through longer distances, there will be some difference in the reflected angles. Hence, high angle rays arrive later than the low angle rays. Therefore, the signal pulses are broadened, thereby results in distorted output. How scattering losses occurs inside the fiber. Scattering is a wave-dependent loss. Since the glass used in fabrication of fibers, the distorted structure of glass will make some vibrations in the refractive index inside the fiber. So it causes Rayleigh scattering. When more than one mode is propagating, how is it dispersed? When more than one mode is propagating through a fiber, then intermodal dispersion takes place. Intermodal dispersion takes place. So since many modes are propagating, so that they will have different wavelengths and will take different time to propagate through the fiber. That's why it go through intermodal dispersion when more than one mode is propagating through the fiber. Explain the critical angle. So critical angle is defined as the angle of incidence beyond which rays of light passing through a denser medium to the surface of a less dense medium are no longer refracted but totally reflected. Define step index optical fiber. So step index optical fiber is a fiber in which the core is of a uniform refractive index and there is a sharp decrease in the index of refraction at the cladding. Define multimode optical fiber. Multimode optical fiber is a type of optical fiber designed to carry multiple light rays or modes simultaneously, each at a marginally different reflection angle inside the optical fiber core. Define refractive index profile in an optical fiber. A refractive index profile is the radial distribution of refractive indices of materials within an optical fiber. Define attenuation in optical fibers. The attenuation of an optical fiber measures the amount of light lost between input and output. Total attenuation is the sum of all losses. So optical losses of a fiber are usually expressed in decibels per kilometer. What are the major components of an optical fiber communication system? An optical fiber communication system comprises three components, major components. One is transmitter, which consists of light source and input signal modulator. And the second one is a receiver. This receiver has a optical detector, signal demodulator. Then the third major component is optical fiber, which is used to pass the carrier waves. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.